presenter will be Heimo Rainer. He is from the botanical garden, and he's a specialist in preserving plants and also bringing the plants now in the digital world. So he will talk about how to digitize plants and how to describe them and how to establish databases and make them available for research. So we are now leaving the world of the metadata and going more to the concrete object and how the object can be transferred into the digital world. The stage is yours.
Yeah. Good afternoon, everyone. I'm sharing my screen. I started working at the Rheinweg University of Vienna. You see on the top right, you see the building. With the main emphasis to digitize, or to actually in the beginning catalog the collections that we are housing. So the title Scientia Amabilis Digitalis is just a running gag at the Institute of Botany. Scientia Amabilis was an old term for the botanical sciences, which was in the old times was more of like the apothecaries, and the medicinal usage of the plants was interesting and important, of course. And it was very often like a hobby, more or less, of the imperial societies. So in Vienna, it started in the Renaissance time, being product of the collaboration and of the connection between Austria and Italy, mainly the region of Tuscany. So what I wanted to show you is how we deal with this digitalization aspects in bigger collections at the University of Vienna. I give some background on the historical stuff, and then concepts of the platform that we built, some projects, and the outlook. In the base of this first slide, I show three logos of three important institutions that are always parallel on my way, like the university, as I told in the beginning, but also the Austrian Academy of Sciences and the Natural History Museum in Vienna were very important for the establishment of this system. So when you study, and as I did in the late 80s, early 90s, one important thing was that you needed to go to the literature published on the topics that you wanted to study. The group of plants that I'm working on is Annona, not to be mixed up with the Latin term Annona, which is the annual harvest. This is a genus and a name coined in the Antillean Islands, and it was already treated in the Species Plantarum by Carolus Linnaeus in 1753 under this name. So what you also have to do is not study only literature, but you also need to go to the field to see the plants that you are studying in the habitat, so in the landscape, and how they grow and how they look like. So I did some extensive field works beginning in the 90s, mainly in South America, since this genus is distributed from the southern Brazil up to Mexico and the Caribbean. You can see here points that I visited all over the two continents. And what you bring home then, of course, is images and pictures of the landscape, of the plants. But this was one trip to Brazil in 2014. But what we also do is we do not only work in the tropics, but also in projects in Austria. This is work that I did together with some colleagues from the Natural History Museum in Hallstatt. So there's a World Heritage Site in Upper Austria. where we were working on plants that that show that there is salt outcomings in the field, like this empty spot you see. There's water which is contaminated with salt coming out of the ground, and there's no plants growing there directly in this spot. What we then do is we prepare the plants that we collect. We press them, we dry them between such cupboards, and press them in newspaper to store them in our facilities. Working on my group, what I also had to do is I had to consult collections, almost all important institutions in Europe. What you see here is the international codes, like FHO and OXF is Oxford, K is Q in London, BM is the British Museum. So there is an international code for institutions housing botanical specimens. And the light green dots you see is the institutions that I visited personally. Then we sent, this is maybe also one of the interesting processes when you study botany. You can ask for loans that you receive material of the institutions that possess botanical specimens. So I have loans from institutions, from 63 institutions, and I'm still wanting to see material for my studies from 3 institutions in the Dominican Republic and in Puerto Rico. So what is the traditional content housed and curated in botanical collections? The groups of organisms that are curated include plants, algae. So algae today is not only one group, but this is many different groups, and fungi as well. There's many different mycological groups now. And what is stored is the objects that we collect and the derivatives, so parts of the plants or parts of algae, fungi. And usually they are dried either, are they preserved either dried or in liquid. And then, of course, as I mentioned in the beginning already, then there is material stored in libraries or housed in libraries, and archival material can be very relevant for us as well. Beginning in the year 2000, I was employed at the University of Vienna to start cataloging. And therefore, I was intending to build a collaboration platform which should have these 4 or 5 main groups of information, or not groups, but main topics of information that shall be captured. One is taxonomic names. This is the scientific names of plants, which is usually the place also where they are physically stored. Then the records keeping or bearing those names of the objects, literature references, and then images should be made available also in connection with these objects. So the preconditions in the late 90s, early 2000s, the institutional structure of the university was originally at the point in Renweg, at the institute in Renweg, all the botanical collections of Vienna were housed. And it's, of course, an imperial setting when these collections dating back to the 18th, 19th century were stored at the facilities in Renweg. And what was also in place already then was a botanical garden in conjunction with the collections of dried specimens. Today it changed, of course, when Austria was reduced to its size of modern times. So the Federal Ministry of Science, and it has was taking over these imperial structures and infrastructures, and it was used for education, science, and research. So we have a professor for systematic botany who used to be the director of the garden. Today it's separated into different organizations. And then there was a close connection always with the Natural History Museum. So in the beginning, what I told you is the collections of all of Vienna botanical collections were housed at Rennweg, and when the Natural History Museum was built, all these collections had to be moved to these new facilities. So at the university, we installed a new collection in 1879. And then the Federal Gardens, this was also a parallel structure. After the end of the Austrian Empire, they were also separated from this concept of botanical institutions. Then the size, coverage, and relevance of the collections, we have about 1.4 million physical objects, about 20,000 living plants in the garden. Then there's 5.5 million objects at the Natural History Museum and 80,000 more or less living plants in the imperial or federal gardens of today. The coverage is global. So the plants and the specimens, the objects, they were collected all over the world. So the relevance of these collections is local, is ranging from local, regional, national to global. And then, of course, there are synergies for botanical data. So there's the scientific community, and there's the general public, and there's objects that are preserved and living. So working together in this aspect or respect would be also desirable, or was desirable already in the beginning. Then we had some workflows, principles, and the systems in place. The acquisition of the collections. So our collections were never closed. So it's still material collected, and new material is coming into the herbarium. And the cataloging of this material is important, of course. What we maybe a detail, this is important when we receive material. Sometimes this is big amounts of material, so we cannot acquire each individual object, but we do the bulk acquisition. So we get, I don't know, from persons when they're retiring, or even legacy material, sometimes tens of thousands of specimens, and they are acquired in bulk. So capture, handling, maintenance, and the transfer of data and metadata is a big issue. The principles for the system that we set up, and this was even pre-Phaidra time or Phaidra times, was that I wanted to have from the beginning a client server installation, so that there is no local installation or software installation necessary. And it should be usable by multiple institutions. Basic information, as I said, scientific names and taxa, persons, geographical data, and the objects should also be captured. Again, another detail from the botanical domain is that when a plant is collected, you can imagine if you cut a branch from a tree, then you can cut 2 or 3 branches, and the duplicates are spread over more than one institution. They are not only kept at the herbarium in Rennweg, but they can be sent also to colleagues abroad. And then there was also a desire to let the specialists work together with the gardeners and the managers of the living plant collections. The software that we wanted to implement and use should have been open source, and to be able to link also the data, this was also a precursor. What we have envisioned from the beginning is that we wanted to have a system where the ticketing should be possible, and documentation and discussions should be captured. And then hardware, we always had this principle of master-slave database management systems and distributed image servers and viewers. The language for the graphic user interface should be scientific and technical. We had a workflow diagram in the beginning before we developed the database, where you see the red is the entire world, blue is the institutional, or light blue is the institutional installations, green is the physical herbarium, and yellow is the virtual herbarium, or virtual digitized materials and catalog materials. And then we have some, in the right-hand side, we have some classification systems which are used for the storage of our material that are relevant. And on the left-hand side, this blue circle is there is always exchange of the material. So we needed to have sort of like this workflow implemented in our systems. Then on this basis, we developed a data model. This is a simplified data model. There is a trigger that triggers an event where we captured the date, the agents, and the locations, geographical locations, and this results in an entity. An entity can be a living plant or a diaspora, so a fruit or any kind of seeds or whatsoever. Could also be an observation, can be a specimen, and then there is a relation to references, in this case meaning literature references. Below the entity, you still see the some of the concepts necessary for the storage, like taxon name, the sex. So if I want to know if it's male or female stage or plants, then I should be able to capture this. Phenology means the stage of the plant when it was collected, either flowering or fruiting or sterile. And each of these entities should be commentable always. Then the data accessibility and visibility, it should be accessible and visible for gardeners and scientists in parallel. Then it should be, again, also possible for external and not only internal personnel or interested people dealing with this collection, but it should also be available for external persons and taxonomic expertise. And then maybe as Raman mentioned in the beginning, standards, metadata standards like ABCD is coming from the biodiversity informatics domain. TCS is the taxonomic concept scheme. This is again from our domain. EDM means the European data model. And then of course there is some general data standards like ISO, OGC is the Open Geospatial Consortium, FOAF is a friend of a friend. Ontology, DC is the DiSSCo.eu. It might be very well known to you. The data handling and transfer, there should be individual objects addressable, but also batches of objects. And inventories for the living plants collections, and indexemium means there's an index of seeds that can be exchanged and can be acquired from outside of the garden. And then, of course, again, some CSV or other file formats for download. BioCase API will show this later. And then it was also important from the beginning to include certificates. IPAN is a certificate which is necessary if you share materials in the botanical gardens, so in the living plants world. Sometimes you have to have phytosanitary certificates when you transfer material from one country to another. CITES is the trading of plants is not free for every group, like cacti or orchids need to be CITES certified. And ABS does mean access and benefit sharing. This is a big topic in the botanical field at the moment. You can imagine the high developed countries send people to third world countries to extract materials, biomaterials from their countries, and then they're doing research like produced and pharmaceutical products and stuff. So this access and benefit sharing stuff is very important. And what we also did is, and I read in the program that there is a separate talk on the licensing stuff. So we did not from the beginning have these licenses in, but we now applied this CC0 for the metadata. There's a discussion in our biodiversity world that all the textual data is actually public domain and therefore CC0. We have maybe a little bit of a different opinion on this. So scientific data in our common practice is always CC BY, share alike, and then sometimes images of living plants are even non-commercial shareable. And this is the system architecture as we deployed it. There's the internal blue in-framed part of this illustration shows there's the database, and then there is some SQL connection to a middleware. There's a business logic internal and web service interface, and the REST service is feeding the portal, and the client browser is then HTTP or HTTPS addressable. Some external services are called via REST, SOAP, and the HTML calls. This is the chronology of the installation. So in the beginning, we had local file system where we stored the images. It was a simple PC attached to the internet so that we could do the client calls of the interface. And it was a Microsoft Access database. So it was a standard software. It was all in one. It was not public. But then in the year 2000, we received some money from an international body. We switched from this local installation to a LAMP. So this Linux, Apache, MySQL, and PHP installation. It was important at that time. There was infrastructure provided by the central unit of the university called Gerda, which was a MySQL server in a version that was not capable yet at that time to have UTF-8 compliance. And it was the hardware components were a physical server at the installations of the university. Image server instances were installed then. So when we digitized the material, we are taking pictures of our objects. This was then transferred to a storage also at the university. In 2012, we switched from this custom code PHP4 to a PHP framework, namely the YE framework, and we upgraded the database to MySQL 5.5. And what we also did is we had in the beginning only just one server, and then we split the servers up, one for development, one for data input, one for access, and a third one for the display on the internet. From 2017 onwards, we switched from the framework, since there was a big difference from YE to YE2. We had to decide if we continue with YE and rewrite all the code. And then we switched to a web service-based implementation using the Java Enterprise stack. You see here some, I'm not a technician personally, you see here some of the components is Wildfly, Apache is Clear, JSF is all this Ajax and Java and JSON services. And we also switched from MySQL to MariaDB since MySQL was overtaken by Oracle again. And at the same time, the virtual infrastructure was erected at the university IT department. So we switched from the physical to virtual infrastructure. What we also had by then is a split of the images in archival and non-archival storage. So the implemented software used for the image display was a JACQ server, and we used it to transfer the original TIFF files that we produced in JPEG 2000 files. From this year onwards, there is a big change in the concept, since we are moving into the semantics world and the IIIF world. One of the last slides then show the cooperation with the IT department and the university library at Vienna. We can provide now the images in a IIIF store and deliver the metadata together with the images. So what I mentioned in the beginning, it was very important for us to be standard compliant. So the database itself, of course, is a a grown system, but we have some mappings then from our concepts to this biodiversity standards. TEDWIC stands for Taxonomic Database Working Group. Actually, it's today BioDiff standards. So this shows you now one image of such a botanical specimen. You see in the upper right corner of the whole specimen, you see a number. This number is the same number as you see here on the right-hand side on this detail page. So 23491 is the leading identifier for this object. Then we have some annotations from specialists, in this case, a colleague from the Stuttgart Museum, Arno Wörz, which identified it as being a type material. So on this basis of this specimen, there was a Serbian plant was described as new. And below the annotation, you see the original label. What we do is we transfer this information that is linked to the specimen into the database. On the right-hand side, you see the detail for this specimen as it shows up in the portal. And then using the TEDWIC standards and the unique identifier, this is going out to platforms like GBIF. I will explain this in a second. And it seems to me that I already in the beginning, I'm more or less following the idea and concept of the FAIR principles, so that people should be able to find the materials. It should be accessible online and interoperable is clear when I imply the standards, and reusable, as I said in the beginning, one of the slides earlier, it's CC BY, so you can cite and you can take this data and for your purposes. This is showing you the installation. So this is one of the middleware bits when we want to transfer our internal database structure and fields. We are mapping those using the ABCD schema, which is again a product from the TEDWIC and enterprise and group. What you see in the middle row is there is general information about the dataset. Dataset itself has a GUID. Then there's metadata of the people and the institutions and the technical contacts. And then below this general information, you have the units. Units is, if I go back this one step, so WU002349, this is one unit. So this, the field number is a number that is given from the collector of the plant itself in the field. Then there is a record basis, which is a preserved specimen, in this case, a dried one. Record URI, this is again the WU JACQ.org /W0029 and so on and so forth. The source ID is clear. This is the institution and the unit GUID. And when we go to the right-hand block, then you see the most important fields mapped, like the full name of the person, the gathering agent's text. It might be more than one person, the altitude where it was collected, in which country it was collected, using the ISO codes, and the name of the country. You see the language is always in English. Then date and time is captured. You can have a date and time range, so it can be collected, the specimen can be collected in a period, so you have time begin and end. Locality text is then an area class and the area name. What we employ is the admin1 regions for countries. And then there's the possibility to store coordinates and a spatial datum, amongst others. This is the data flow then between JACQ and an external aggregator, or two external aggregators. One is the Global Biodiversity Information Facility. The second one is Europeana. And what I just showed, this ABCD schema mapping metadata from our system, from the JACQ system, to to the JACQ ABCD standard is used for the delivery of the data to GBIF. On the left-hand side, you see that there's several people, and below the people, you see that it's a responsive design, so you can do the data entry and everything on multiple devices. And the database stack is going into or through the middleware BioCase, and it's delivering the data then to the GBIF or the GBIF Austria and the Europeana portals. This is the this is to show you how the data are produced inside the JACQ system, then show up in the GBIF platform. In this case, the dots that you see in the different heat map colors is the number of records that have coordinates are showing up in red. In orange, a little bit less, and in the lighter the color gets, the less number of specimens per region are shown. What you can see also here is the relevance of our collection. So from this 84,000 occurrences, 51 are with coordinates, and they cover more or less global area. Below the map, you see some of the records that have attached images. What have we reached so far? So the system is, as I said, from the beginning was intended to be used by not only the university herbarium, but by multiple institutions. As I said, these abbreviations or acronyms are following an international standard of herbarium names. WU stands for Wien Universität. W is the Natural History Museum. GZU is the University of Graz. GJO is the Natural History Museum in Graz, and so on and so forth. And since I realized that the audience, there's several people from Padua, from Italy, we have recently some interested institutions. One is PI, this is the Botanical Garden in Pisa, that joined the consortium in 2016. And this year we have two new members from Italy. One is the University of Pavia, and one is the University of Torino. Torino is especially important since it houses a very important collection from the Piedmont and so the Southern Alps. And we also have 4 gardens that joined the JACQ consortium, all of them at the moment still from Austria. Content-wise, what we reached is, this is a date in September this year, so it's a little bit more than that already. So we have, out of these 40 plus institutions that joined the system, more than 1.7 million records of objects. Important from a botanical perspective is the number of type specimens. This is material on which scientific name is given to plant species. About 53,000 records of living plants. And since this is a system where we jointly work together, so all colleagues from the institutions can not only put in the data in the system for their own objects, but also scientific names are introduced using the workforce of all of the consortium members. So that this number of 425,000 scientific names that we use is based on the objects that we have in our collections. What we also did is we captured 34,000 or almost 35,000 literature citations with possibilities to link out to DOIs or to the online versions of these references. Then we have a platform on our own, which is shown you here with some acknowledgements. This is institutions, as I mentioned in the beginning, the University, the Academy of Science and Natural History Museum in the first row, and a very important institution now joined also the JACQ consortium some time ago is the Berlin Botanical Garden. This in the top row, the 4th from the left. And others include ministries and major funding agencies like the Andrew W. Mellon Foundation. I mentioned in the abstract also the role of the university. So why we chose to go into this client server and virtualized infrastructure of the university is it's a very stable infrastructure that has almost 100% availability. So since the year 2004, when we moved from the local installations to the LAMP installations, we had only 1 day of interruption, which was caused by some hardware of failure of the ARCONET installation or infrastructure. And this was only lasting for less than 1 day. So I had no serious interruption of our facilities. Then for the metadata provision, we have one installation of this middleware at the university. What you see here is there is a publisher, University of Vienna, which is providing one dataset, which is the Herbarium dataset, and it's hosted again by the publisher. For the University of Graz, we do the same. So we have one mapping that we spread over the institutions. And we do this 25 institutions now in the JACQ system. We're going into the semantics world. So we have about Wikidata ID and botanist ID and ORCIDs for the number given here. We have scientific names reference to the outside world. So we directly link out our names to the semantics. One installation provided by the Botanical Garden in Berlin is on the basis of our external identifiers. There's a seat of botany pilot set up where you can see the Wikidata ID from Theodor Koczi, an Austrian botanist, and specimens are provided by this 27 institutions inside JACQ and outside JACQ. Projects that we've been involved include a Global Plants Initiative, where we digitized all the materials from the type specimens. BHL Europe was from literature. Open Up was granting the materials, providing the materials to Europeana. And Reflora was a project dealing with the digitization of accessions from Brazil housed in Austrian herbaria. Outlook, and this is my last slide, is we at the moment have 130,000 specimens recorded inside JACQ out of 1.5 million. And we have already 34,000 taxa attached to these objects. And then there's an important project now starting in January 2021. We want to digitize actually all of the specimens of the herbarium, and this is done jointly with the library of the University of Vienna, the Phaidra installations, and the central IT infrastructure. Then next will be the extensive linked open data initiatives that we follow, and we want to hook up two important things on the European level, apart from the Austrian scientific open collections, is the distributed system of scientific collections and the European Open Science Cloud. And the last line here in this slide is what we can never guarantee is once we have 1.5 million objects digitized, we cannot have the personnel to curate the digital versions of these objects. So there might be the only solution to have a community data curation for these objects once they're digitized. And this was my presentation. Thanks for listening.
Thank you, Heimo. Thank you to give us insight in such a a large project that runs over a long time, and with so many different institutions involved. And that's is all about sustaining the data, sustaining so digitalization of the object, so sustaining the information, and also to define on a community-based level standards that it's possible then to share all the informations what you have on these several institutions which are connected over the network. So this is a great effort what you do, and I see it also from the discussion what we have seen the last talks and also from the roundtables. I'm curious in how you bring this big vision of this infrastructure from spread over different projects and different funding streams.
What I always thought is, and what I have seen personally is that there's projects dealing with different perspectives on the same objects. So producing data which are separated from each other. So what I wanted to have is I wanted to have one pool of data which is inside one system, and then it's delivering out its results to, on the basis of projects, to different stakeholders, to different funders, but all of this is going into one data pool. And as I said, as we have in the botanical world, we have this system of duplicates. If a record of a certain collection event of a certain plant has been already taken up, this is usable for all the other institutions inside the same consortium. The same is true if we are working on the materials. The work done in one institution is then directly usable for researchers and colleagues of other institutions. So this is one pool of data, delivering data to different portals, to different projects, to different analytical methods, and sharing a common platform is the main vision of the whole thing.
That's nice, and this is also pretty much one of the ideas what we have, but more in a broader context, because we want to support different research disciplines. And also the other thing what you could show in your presentation is the different infrastructure and how they are working together.